Alright students, we're going to take a look at doing integration when the chain rule is involved. And I know that the chain rule is involved in this problem as soon as I look at it because this guy out here on the outside of the parentheses is more or less, and the key words here are more or less, the derivative of what's inside. Because the derivative of what's inside is of course 2x, and I know darn well I've got a 4x out there, but all I care about is the variable part. We're going to fix the coefficient later anyway. So all along during the problem, since I'm going to fix the number, I sort of ignore the number. So my personal preference at this point is to take that 4 and just throw it off to the side. So I'm going to take that 4, set it off to the side, and I'm really just going to integrate the rest of this expression. Now remember, I'm also counting on this guy being the derivative of what's inside to just appear magically when I need it during my check. So I really, to be honest, don't even consider the x. So all I'm really going to worry about is taking the integral of my parenthesis to the 5th power. And of course, this is the basic power rule, so when I take the integral of this, I just add 1 to the power and I call it a day. Now I know that I could go ahead and divide by 6, and if you want to go ahead and do that, you please feel free to go ahead. It won't hurt anything because it's just going to change the number, and we're adjusting the number anyway, so who cares. But to be honest, it's easier just to go ahead, add 1 to it, and call it a day at this point. So now I think this is essentially my answer. If this is, oh by the way, don't forget I still got that 4 sitting out there that will come back into play later. But if this is essentially right, when I take the derivative of this guy, I should get this guy. And of course, you and I both know that I've ignored a lot of the numbers. So I know that the numeric part of the problem is going to be incorrect. I'm treating it like there's nothing there. There will be something there that we need to get rid of later. Okay? And whatever we do later, remember, it would have had to have been here really all along, and we would have just set it off to the side like we did the 4. So let's see now. If this is the right answer, let's go ahead and take the derivative and see if it really is this beginning answer. So when I take the derivative, I move the 6 down in front, subtract 1 from the power. That's the basic power rule, of course, and then I multiply by the derivative of what's inside. Now there's some simplification that can occur here. I have 6 times 2x, which of course is 12x. So now I have 12x times my parenthesis to the 5th power, and you'll see, as we predicted, that didn't quite match what it was supposed to. There's no 12 sitting in front of this, so there shouldn't be a 12 here now. Well, how the heck do I get rid of that 12? Well, what I'm going to do here, frankly, is just simply divide by 12. Or, if you prefer, I could just multiply by 1/12. And now that 12 would cancel, and this would match perfectly the way it's supposed to. But I can't just throw in a 1/12 at the end of the problem because it's convenient to do so. What I'm really saying is it must have been there all along. So there must have been a 1/12 here to begin with, which of course I could have just set off to the side, done my derivative the way I wanted to, and then multiplied by the 1/12 at the end and gotten my perfect answer. So now what I need to do is take those pieces that I sort of just set off to the side and combine them and fix my answer. So the 4 would cancel with the 12 and leave me with a 3. And I've chosen in this case to go ahead and instead of writing this as a 1/3 out in front, to merely put the 3 on the bottom. But I want you to realize, of course, that 1/3 in front, or dividing by 3, is exactly the same answer. Now, let's go ahead and check our problem. If I am indeed right, if this truly is the integral for what I started with, I should be able to take the derivative now of this and end up with what I had to begin with. Let's check it and see if it works. So again, what I want you to see is I'm going to take the derivative of this answer and prove that it really is equal to my very original problem. So let's give this a shot. Let's take the derivative. Well, the first thing I want to do, of course, like I always do, is take that 3 and move it off to the side. So basically the 3 is in the bottom, so I'm going to treat this like it's a 1/3 out here. And just take the derivative of this guy. How do I take the derivative again? Well, of course, I pull the 6 down in front, subtract 1 from the power, and then multiply times the derivative of what's inside. Now there is all kinds of simplification I can do here. I can cancel the 3 with the 6 and make it a 2, and then I can combine my 2 times my 2x, which of course leaves me with a 4x. And I would like you to note that the thing I have here at the end truly was the very original problem that I had to begin with. So I took the integral of what I was given, came up with my answer, and then proved that the derivative of that answer really was my original problem. Remember, these are opposites. So if the derivative, or the integral, of my original problem was this answer, then the derivative of that answer must be my original problem. And I hope at this point that that gives you a basic idea of what's going on. If not, then please come to one of my office hours or write me an email and ask me a question, and I'll see what we can do to get you straightened out.